All right, 1.5, solving equations with variables on both sides. All right, this is just like solving simple equations, solving multi-step equations, except now they get a little bit longer even. Starting off, we have two new ideas. We have an identity, an equation that is true for all variables. All right, that would be something like if I told you, well, x equals x. You'd say, well, yeah, of course it does. Similarly, we could say like x plus 1 is x plus 1, or 5x is 5x, or just plain old 4 equals 4. Those are all identity. So if you're solving an equation, and in the middle of it, you're like, well, this is the same thing on the left and right side of it, then that's probably an identity, all right? Next up, we have no solution. An equation that is not true for any variable. So this might be something like, I don't know, x plus 1 equals x, right? When is that ever going to be true? And the answer is it won't, ever. 4 equals 5. Another statement that just won't be true, okay? So those two things we need to keep in mind. So it could either be an identity, it could be no solution, or it could be a normal old problem where we get an x equals 5 or an x equals 10, whatever it is. So let's look at number 1 here. Now here there's two different ways we can approach this problem to begin with. And I'm going to do the kind of a tricky way. One way, and the way that we probably normally would do it, is to distribute this 4. But there's one other way that I think is just a little bit easier. What I'm going to do is I'm going to divide by 4. And the reason I'm going to do that is because I look over here and I see the 12. 12 divided by 4 is 3. It gives me a nice answer, right? If that 12 was like a 15 or something, then I'd say, well, 15 divided by 4, that doesn't give me a nice answer. But 12 divided by 4 does. So whenever I cancel out these 4's, and I get 3d minus 1 is 3d. Now we look here, we have 3d minus 1 equals 3d. When would that ever be true? And the answer is it won't. This is something kind of like the x plus 1 example that I got. Oh, excuse me. That's not like that. It's kind of like this one here. The x plus 1 is x. There it is. So this is going to be a no solution. There is nothing you could plug in that would let those be true. Next up, number 2. Here we have some fractions. And there's two ways to approach fraction problems. One of the ways is to get rid of fractions right away. And we could do that. I'm not going to do it this time, but you could. We could multiply everything by 4 and get rid of those denominators. Instead, I'm going to, if I can erase, there it is, I'm going to just solve it like this. So I'm going to start off by adding n over 4 to the left side. That cancels those. I'm going to be left with a negative 3 on the right. And then on the left, I'm going to have n over 4 plus n over 4. Well, that's going to be 2n over 4. To simplify that, I'd get n over 2 is negative 3. And then to finish up, I need to multiply by my denominator, by my 2. So I get n equals negative 6. Alrighty. Next up, number 3. Oops. Uh-oh, what did I do? Well, that's messing up on me. There it goes. Here, I've got that 7 on the right side here that I need to distribute. We could distribute it. That would be a good way to do the problem. You can do that on the homework. But what I'm noticing is that 21 is a multiple of 7. 7, well, that's a multiple of 7. And then we get the other 7. So what I'm going to do is I'm going to divide everything by 7. Right? You have to divide each thing individually. 21 divided by 7 is 3. Negative 7 over 7 is just negative w. And then over here I get 3 minus w. Well, look at this. We've got 3 minus w, 3 minus w. This is an identity. And lastly, number 4. You bike for 3 hours to reach the beach using the same route, or the same route. I don't know what route, whatever it is. The return trip takes only 2.5 hours because you travel 2 miles per hour faster. How far did you ride your bike going to the beach? All right, so let's look at this. We drive for 3 hours at x miles per hour, and then we drive 2.5 hours at x plus 2 miles per hour. So let's set those equal to each other, right? Because hopefully there wasn't a massive earthquake that shifted the ground. So it should be 3 times x equals 2.5 times x plus 2. Right? That should be that. What we're writing there is distance equals distance. The distance there equals the distance back. Distributing this 2.5, we'd get 3x equals 2.5x plus 5. And then we'd have 0.5x equals 5 and x equals 10. So it's 10 miles per hour. 10 miles per hour. Now, if we take this, we can plug into this guy here and say, well, 3 hours at 10 miles per hour is 30 miles. So the beach was 30 miles away from your house or wherever it is. All right, lastly, we want to just remember what the absolute value is. I think we've done that before, but I just want to remind us. Remember that the absolute value of something makes it positive. So if it's a positive 5, then it just stays 5. If it's negative 6, then it turns into a 6, right? Another way of thinking of absolute value is it's the distance from 0. Right? And we think about distance as being positive, right? A distance, we don't say, well, I drove negative 5 miles to school. Right? You don't say that. So one way to think about this would be to say, well, we've got a number line with 0. Here's 5. This is 5 units. And then here's negative 6. This is 6 units. Right? That's one way to think about that. You think about it as the distance from 0. So that's absolute value. You'll need that for some of your homework problems. All right, that is all.